Hello, everyone. Thank you for joining us and welcome to today's webinar, Avoid Dangerous Road Conditions with Hyperlocal Weather Info. My name is Jody Lee and I'll be the moderator on this webinar. I'm excited to be joined today by Eric Dixon, Senior Product Manager at Harris Geospatial Solutions. Eric has over 20 years of engineering and design experience in ground-based imagery systems, situational awareness, and data processing. So welcome, Eric.
Thank you.
Just a couple of housekeeping items before we get started. I've muted the phone lines for all attendees. So if you have any questions at any point during the webinar, feel free to enter them into the questions chat box and we'll try to answer as many as we can at the end of the presentation. We are recording this webinar and we'll have it up on our website at harrisgeospatial.com in the next couple of days. We'll also email you a link to the recording, this slide deck, and a few helpful resources, which you're welcome to share with your colleagues. So next. Eric, you can go over the agenda now.
Okay, thank you. I want to thank everyone for joining the webinar. Once again, my name is Eric Dixon. I am the Senior Product Manager here at Harris Geospatial Solutions. We're going to talk a little bit about a little overview of Harris, and Jody will give a short overview of Harris Geospatial. And then I'm going to talk a little bit about the technology, particularly about the Internet of Things and how sensors are becoming more and more ubiquitous. And then I'm going to talk a little bit of how the convergence of some of these technologies with machine learning is playing a role to help us solve some of these problems that we see down in the weather and transportation space. I'll give you an introduction to Helios, which is a product from the Harris Corporation that is actually implementing these new technologies. And we'll go over some capabilities, examples, and also I'll give you a little feel for a live demonstration of what the technology and the data looks like visualized a bit. And then we'll end with some question and answers, okay? And I'll turn it over to Jody.
All right, just a quick overview of Harris for those who don't know who we are. Harris Corporation is a global technology leader providing electronic warfare, avionics, air traffic management, space and intelligence systems, and weather systems to customers in more than 100 countries. The headquarters is based out of Melbourne, Florida, and we have about 17,000 employees worldwide, with 7,700 of those being engineers and scientists. So next slide. Within Harris's Space and Intelligence Division is Harris Geospatial Solutions, where Eric and I work. We offer end-to-end geospatial solutions, including advanced geospatial analytics, machine learning, and remotely sensed data to help our customers solve hard problems and make better decisions. The industries we're serving mainly are defense and intelligence, federal and civil government, utilities, precision agriculture, and transportation, specifically rail and DOT. So now I'm going to turn things back over to Eric so we can get started.
Thank you, Jody. So I'd like to start this webinar a little bit about talking about the technology. And we'll move into sort of the use case and how this has applicability down into the weather and transportation space. We see at Harris a convergence of several technologies coming together, and we see it on the imaging side of the technology. We're also seeing the merge of technology in both the weather and transportation spaces, as we're seeing both weather and transportation moving closer together in the marketplace, and it's really all being driven by the connected car space and those technologies that are moving us more toward the autonomous. But the Internet of Things is what you would call a buzzword. And to a lot of people, buzzwords don't mean a lot. But what Harris is really trying to do is bring to life that buzzword. And the real premise behind the Internet of Things is to detect new types of information that's normally not in the context of the device's original purpose. Right? And that's something that a lot of people don't always understand, because if you look at the upper right image, right, you see a traffic camera, and normally you would look at traffic or say, I can see traffic. But in reality, Harris sees a lot more things out of that camera image, and there are a lot of things in that scene that can be extracted from that image. So we are really trying to apply this technology, or this buzzword, right, the Internet of Things, and bring it to life. The other thing that's coming or merging together is the surveillance camera. We see it; they're all around us. They're sensing. We never really think about them, but they are very instrumental in our everyday life. We don't really look up, but when everyone came to work or wherever you're at, you went by tons of sensors, and they're always sensing things. The surveillance camera is probably the mother of all sensing devices on the imaging side, and it's growing and becoming ubiquitous in our lives. And as you can see in the chart, the number of EO cameras in vehicles, cameras are basically everywhere, and now they're down in our cars that we drive every day, trying to help us on the safety side, right, for driver safety. The other one that we'll talk a little bit about is machine learning, and it is really proving itself that it has the ability to solve problems that we never envisioned on the traditional computer vision side of things, and I'll talk more about that later. But machine learning, applying that against some of these Internet of Things devices and sensors, are really changing the paradigm of what we can actually detect from some of these sensors. These are all emerging, right, in the weather and transportation space, and we wanted in this webinar to talk a little bit about how we're applying these converging technologies in the weather and transportation space. So one of the biggest areas that we focused on, and this webinar will focus on, is the need for more granular ground foundational data. We do a lot of forecasting. We have a lot of assets that are not only in satellite, or looking down from satellite, from aerial, even from drone now, and now on the ground. But I hate to mention politics in this conversation, but unfortunately, all weather is also all local, right? And for many people, the best forecast is really still to look out the window. Surprisingly enough, we've talked to National Weather Service forecasters at the forecast offices who still look out the window before they put together a nowcast. I guarantee that many of us looked out the window this morning when we got out of the bed and before we left the home. And why is that? That's simply because there's a little bit of frustration, or maybe a lot of frustration, with the inaccuracies and the generalities of weather forecasts. And it's not necessarily that the forecast is necessarily wrong, but it's not in the context, right? It doesn't give us the context of what we need to solve the problem that we're trying to find out, right? We're trying to look for. So I think the biggest issue is what happens in the atmosphere is not always what happens on the ground. And we all are familiar, those who are at DOTs, those who are trying to do anything, we realize that the atmosphere is a little bit different than the ground. There's weather phenomenology and phenomena that happens that even though you may have lots of clouds that have lots of water in them, that there can be layers of warm air, and sometimes the rain doesn't hit the ground, sometimes it does. So even when the forecast is correct, expected zones of impact are very, very different than the actual zone of impact. And that's where this whole locality or hyperlocal or mesoscale information is very important. So we know a lot about the weather, right? And I'll quote the side package, but what really, or the side note, what really matters is the weather on where we're at, right? The location of where we're at. So we're seeing this evolve, right? As technology improves, location-based services, everything is into granularity, and we're trying to help solve that problem. Okay, so some of the goals that we're trying to solve here at Harris is filling the gaps in the foundational data. We believe that having a great foundation is the way to start to pull up additional capabilities from the foundational data into better prediction and better models and better forecasting. So we're really out to kind of provide the largest terrestrial image analytic network on the planet. And that is there to support, and we'll talk about Helios and how this does that. And that is really trying to support, right, trying to provide additional ground data around what exactly is going on at the current time. We use machine learning to extract numerous types of phenomenology. So right now we're looking at the environment. We want to be able to add fidelity to what's existing in the current detection capability or observation capability that's in the current weather enterprise. We want to be able to fuse other types of discrete data, and we want to add new observation types to the knowledge base. Thus, we can improve current decision making and forecasting. And that's where we think the improvement, or we can drive the improvement as we try and look at new ways of prediction, new ways of forecasting, and improving models, and particularly in longer term models. So we want to really provide a solid foundation that we can start to do new predictive capabilities against. So I'll talk a little bit about machine learning and the part that it plays with us. So I'll talk a little bit about the problems in traditional computer vision when looking at imaging on systems that are, we'll call them the Internet of Things, right? These are existing terrestrial systems or drone systems that have varying spatial resolutions, varying resolutions of compression. They have image variation, so one image doesn't look like another image. This is very difficult with traditional computer vision that's looking at pixel-based processing. Machine learning is reframing that whole picture, and now it has the ability to extract information, and particularly environmental and traffic conditions from existing terrestrial camera networks. And I can extend that out even into the drone sector because that same sort of camera model is similar to what we're doing with CCTV cameras. And I think the big hitter is that we can basically repurpose any camera from a dumb camera, maybe a camera looking at traffic or surveillance, and we can convert that or retrofit that into a smart sensor without ever touching the hardware of the system. And machine learning is allowing us to go to customers and say, you don't have to reinvest in your existing infrastructure. So it's maximizing the investments that you're making on the infrastructure side. So this kind of capability complements and densifies, right, any existing DOTs, mesonet site locations. It scales with the DOT. It scales with whatever network that you may have. So, for instance, if you have 1,500 cameras in your DOT network currently now, and you upgrade to 3,000 cameras, the capability that we're using on Helios scales without you ever having to make any kind of additional investment in software or a change to a specific type of camera to use the system. So the capability is scalable as you scale your network. So you're getting high value for the capability. It also demonstrates a high value value add and repurposing existing investments. So states spend a lot of money on their existing infrastructures. They're trying to find more ways that they can leverage that infrastructure to add value to their citizens These are taxpayer funds that go into these infrastructures, and the more value you can bring out of those capabilities, the better off, and particularly if they're adding to public safety and better awareness of these types of hazards that could cause fatality. And it improves ground occurrence detection. So there are many, many types of phenomena that are very hard to capture, and they're very localized. Fog is one of them. I mentioned partial snow in that last paragraph simply because many RWIS systems look at snow, and they sometimes get confused with the where the wheels of the cars. So where the wheels of the cars may be, they may be clean of snow, but the rest of the road is clean. The technology that we're putting across shows a complete sort of picture of the road, even going to the point of figuring out which particular lane has snow cover and which one does not. Okay. So I'm going to talk a little bit about and give you a little bit of a live demo. This is sort of what Helios is in a glance. It's really this very large cloud-based system that ingests millions of cameras. It has the capability of taking in millions and millions of cameras real time. It can ingest full motion video as well as single frames from any IP camera or any network that can give us access to that camera. We pull that information into that infrastructure. We normalize the data, and then we produce analytics from that data. So we're able to look at the imagery, use machine learning, as you can see from the bottom, from machine learning to statistical analysis and data mining, and then we provide you detected phenomena from a simple camera image. We're able to do that using one frame of imagery. So in traditional computer vision, you may need multiple frames of imagery to make a detection, doing a pixel-to-pixel comparison. Machine learning eliminates that block, right? That roadblock that prevents many traditional computer vision processing products, right, and providing that type of information. So it fills that hyperlocal kind of gap that's missed by radar, right, satellite, traditional weather stations. I'm going to come out a little bit and just give you a little brief look at the Helios system as a whole. So just pull out, I'm hoping everybody can see what I see now. So Helios is really, and this is a visualization of our web application. Helios is really this large network, and I can zoom in and give you an indication of the number of cameras that we have existing in the system. So Helios is this large camera network that we have cameras just about everywhere in the United States. And what it enables us to do is, in real time, look at every camera. And every 5 to 10 minutes, we can take an image from each of those cameras and produce a derived observation from that camera. It's large in scale, over 40,000 cameras. I'm going to zoom out a little bit here to give you an understanding of where those assets lie. So we have the United States, Alaska. Alaska is brought to us, giving us access not only from Alaska DOT, but also the FAA cameras. We've started to populate into the Canada area as well. And I'll try and give you a little bit more. A little slow on my end, so I'm sure it's a little bit slow on your end. Finland and Sweden has coverage. The UK has full coverage. Let's see if I can zoom in for you for that one. Okay, and New Zealand. Okay, so I'll give you a little bit of zoom. I'll come back into the United States and give you a small bit of understanding of what we're doing with the technology. So each one of and I'll try and zoom in kind of close. So the more you zoom in, the more cameras that you're able to see. So I'll come into the Washington, D.C. area just to give you an idea of the coverage there. All right. So each one of the cameras is a camera feeding us data real time. So as I mentioned before, the cameras are sort of the foundational sort of network that we are trying to build and grow into the millions to provide that foundational set of data. What we're able to do is, a little bit slow here, we're able to take those cameras and instead of giving you the camera capability, we can now give you what's called the analytic viewpoint of it. So I'm hoping everybody's viewing this. Okay. So instead of a camera, you're now getting analytics, right, that sort of tell you exactly what's going on. And you can look sort of at the legend at the bottom to kind of understand sort of what we're seeing from the analytics every 5 minutes across this. And I'll come up into an area that I know is having some weather. If you get up there. So we're seeing some weather up into the northeast. So right now I have the visibility analytics sort of running, and you can see the red dots where we're seeing sort of hazy, not so, it's not bad visibility, but it's somewhat reduced visibility. And I can touch, wow, I can't really maneuver well. So I'll touch one and give you an idea of what we see. So what we're seeing here is you can see the history of that particular camera going down the scroll. And what it's reporting is the icons give you an idea of what we're seeing. The one to the left is visibility. So it's saying a little bit hazy. You can see from the image that the image is definitely hazy. It's telling you the middle icon that there's some road wetness. The road is wet, right? And that it's not raining. So those kind of icons are capability, right? And I can switch that out if I want to look not at visibility, but if I wanted to look at road weather, I can also turn that analytic on, and it'll give me a different viewpoint of not of visibility, but whether a road is wet or dry. So all of these roads are looking somewhat wet. You can see each icon that I touch. I can get an image that shows you sort of why we, or the validation image that shows you why that analytic actually produced that particular detection. So in essence, you really don't have to look at a camera anymore. The analytics are really doing sort of the work for you. So the system is constantly making these types of detections, and it's doing it pretty much across our whole network in the United States. So I'll try and zoom that out a little bit. give you a look at all of the analytics that are kind of running to give you that picture. Okay. So that's consistently running throughout the system. If I wanted to look at a particular observation or particular area, I can basically say, well, okay, show me all the roads that were covered, let's say with full snow in the city of New York or in New York. Let's say the state of New York. I can simply enter that in, and the system will go back and find me all the images that over the course of, or at least at this current moment, there's full road snow in the state of New York. And I can alter that look. I can go back in time for each one of these images. Go back in time for that particular image and look at all the day's observations and get a timeline of how that road actually has been looking over the course of time. And I can do that with practically any of the analytics that Helios produces. So say I was looking at New York and I said, okay, I don't want full snow, I want partial snow. So maybe some of the roads that have partial snow on them, it'll give me a different set of imagery to show partial instead of full covered snow, partial covered snow. Right? So I can run through all of those scenarios through the analytics, and you get full complete search of not only geospatial, but textual search across the system. So it sort of gives you a great picture of not only what's currently happening, but what has happened, what has transitioned, what has been at 1 minute snow and has turned to wet, or what has been wet and has transitioned to snow. Okay, so I'm going to move a little bit on more toward our PowerPoint. Okay, so just to go through some of the bullets on the side. So it is a web-based, right? About 40,000 cameras. We provide an API, so you can, whenever we see an alert from our system, you can get a push alert or notification. That could be email, that could be onto your smartphone, that could be onto any mobile application that you have, that could be into any center, or you can do a pull from our system. We have historical data archives. So if you're looking back over time and want more granular data about what is going on over the course of your roads at a more granular look, we have historical data archives of not only the detection, but also all of the imagery that goes along with the detection, so that you have a way of validation and verifying. And of course, in our network, we're seeing more arterial or secondary roads come into our networks. We think that will continue, and we have initiatives on the connected car side that we're actually pushing or starting to pull in connected vehicle car data analytics, and we're actually providing that into the system. We'll give you an example of that. Is this is one of our UIs of our snow plows. So this is given to us from the Iowa DOT. We have Iowa and Minnesota. We're now ingesting their imagery into the Helios data to give us a much more dense look at situational awareness. And then we're looking at those images and providing analytics back to our customers. So not only are you seeing arterial roads, more than just interstate, but arterial and secondary roads coming into our system, but you will also start to see the connected vehicles, connected fleet vehicles, all now being part of the infrastructure or that platform that we have that can ingest all of that data. Right? Okay. So I want to talk a little bit about where we're trying to go and where we think the technology or how we can build against the technology. So in our case, we really think the most important or critical aspect is obviously the detection of these observations, but it's really about impacts of weather. So real-time observing of current conditions really is the big validator, right, for current forecasting. They need to understand is what we're forecasting really happening? And as storms move over areas, there's a need also to do real-time surveillance. So we're looking at impacts on the transportation infrastructure. How is that affecting roads? How is that affecting other critical infrastructure that we may have imaging systems that can help us see how a storm is affecting them? How are ground conditions actually differing than what's expected? That's a big point. We expect certain things to get 8 inches of snow, they get 2 inches of snow. We like to understand that and know exactly what's going on as storms progress. And how have conditions changed over time? And that's obviously important when you're trying to understand how conditions differ from what's expected. If you're seeing trends and durations of things that maybe you weren't expected, you want to understand that with good granularity, not only spatial granularity, but temporal granularity. So that's why our system has the capability, if you feed us data once a minute, we can actually produce an analytic once a minute. The majority of all of our camera systems feed us, data maybe 5 to 10 minutes a frame. We do have some cameras that give us full motion video, and we can accelerate the capability of producing analytics to almost real time with the platform. So impacts are very important and things that we are sort of trying to deliver to our customers. So it's all about, not only traffic, roads, weather, and the timing, but that all sort of dictates the impact. The other aspect that we're looking at is we're trying to understand different phenomenology in the scene. So weather is an important part. Traffic is another important aspect, but there are just a lot of different aspects of both of those that we're trying to understand. Incidence, congestion, flow, density, all of those kinds of things we are looking at extracting out of the image scene for the Helios technology. Objects, you don't want to open up an HOV lane with a car impeding that particular lane. I threw vegetation in there simply because every time I look at our product, I look over seasonal, I see the trees change, right? They go from green to brown to no trees, no leaves at all, to green again. So we see a lot of information about seasonal changes in vegetation, right? Encroachment, things like that. Those are kind of the phenomenology that we are starting to sort of extract from the image that we think can add to the observation types when we're doing forecasting, and transportation is doing work to help protect drivers, right, and protect the public. So in the box, I put some other things that I think may be important down the road, and these are just things to whet your appetite, to give you sort of some indication of what might be of interest. On the Harris side, all of those are of interest, and eventually will become part of what we're doing in extracting the information using machine learning. The third aspect that I'll get to is really about how do we correlate this for improved prediction. And I talked about that on a previous slide. It's really getting to that predictive nature of things is really the goal. We believe that there needs to be more granular route foundational data. So we've started at the foundation, but we think that's the building block for actually improving current forecast, and also for better validation of forecasts, and also in the creation of new types of prediction. So the correlation of weather and traffic, road behavior, right? As weather we see seasonally, as weather goes across particular camera images, we can start to understand that road behavior against weather, against all sorts of different types of aspects that we extract from the scene. Patterns and trends and anomalies, I'll talk about that, I think, in the next slide. Look ahead conditions. You know, if we have the public out traveling roads, we want to be able to tell them 10 miles ahead, you know, you're going to go from slushy roads to snow-covered roads. Those are the types of driver safety aspects that Helios can provide DOTs. And that can even extend into the messaging signage that transportation company or agencies put out to the public to warn the public for driver safety. And of course, advanced data science. So taking some of the data that you're getting from Helios and combining it with your other decision support systems to produce, right, to solve more problems, to answer more questions about how is this road actually looking? What is going to happen in the future? What should we be telling our public, the public, about these stretches of roads? All of those are the three bullets, or big answers that we're trying to pull out of some of this foundational data. And to talk more about sort of traffic. I think I'm a little bit ahead of myself. So let me step back for a second and talk to you about what's available from Helios. So like we said, we have road weather, visibility, and precipitation. It's derived from these this big network that's continuously increasing, and we update every 5 to 10 minutes. What's available is a host of road weather observations. So of course we do dry roads. So it's not, you don't see it here if you look at the bottom middle on road weather. So we can tell you when the road's dry. We can tell you when the road is moist, wet, and then we can also go into ponding and pooling. And ponding is our efforts to move more into the phenomenology of flooded roads. So we have a lot of requests for trying to understand when a road has been flooded. Our ponding and pooling analytic is our next step, or actually, right, it's our step. Our next step from ponding and pooling will be actually flooded roads. And we're in analytic training or model training for that currently. Snow slush, partial covered roads, and then full covered roads. All of that fidelity is simply sat in road weather so that you can actually start to understand whether a road is improving or degrading. So instead of just giving you, bad and, good, we give you sort of some of the fidelity to look over time, temporally over time, to see if things are trending, degrading or improving. And that's true with all the road weather capabilities out of Helios. If you go up above road weather, we have precipitation. Precipitation is really focused on moderately heavy to heavy precipitation. So I think that's, if I can get my numbers straight, that's 0.76 millimeters per hour on the rain rate. So it's pretty heavy duty rain that we're detecting from that analytic. To the right, upper right, is visibility for smoke and fog. So we give you a whole host of fidelity in that one as well, all the way from good to hazy, to reduced to poor. And you can combine our analytics. For instance, you can combine the wet road with the hazy visibility analytic, and that will give you light precipitation. So we've made it so the analytics, when you search for data out of our system, you can actually merge or combine analytics to get a actually new analytic for you. And then finally, at the bottom right is our road ice formation. That is actually a derived product from our WIS stations that are giving us road temperature. And then we're making some interpolation with our road weather capability to give you very localized road ice formation warnings. All right. Okay, and I'll move on. So I wanted to give you a little bit, I kind of showed you what our, and I'll go back just for a minute. I gave you an indication or a look at what our actual UI looks like, right? Showing you real conditions over time, right? I'm sorry, not real conditions, but real conditions as we see them today, right? So if you're looking at visibility, these are our current conditions that we're looking at. I wanted to share with you a little bit more power that you can pull out of the data that comes from Helios than just the current conditions that you're getting in this particular UI. Okay. So I did myself some just advanced visualizations of the data with an open source visualization tool called Kibana, which is part of the Helios Elasticsearch capability. And what we did is I simply just pulled out a heat map of, we took Colorado, and we looked through around November 5th through the 12th of this year. And we did a heat map of where on our network we saw full snow the most over that week in Colorado. And this gives you a good visualization when you're looking at a more dense network of where things are actually occurring. So you can pull the data from Helios and do these kind of advanced kinds of temporal advanced capabilities of understanding where things have happened that can help you understand what's going on in your DOT at a much more granular level, or where we actually have our network situated. Another one that we did that shows you some advanced analytics is another map. It's a different type of heat map of where we saw sort of full road snow, right? So not a heat map, but actually where on our camera network, right? In our cameras that we see full road snow the most over the course of that time period. That's all accessible out of the API. This was a simple advanced visualization done by Kibana, which is sort of an open source, simple to use open source visualization tool. But gives you the capability or shows you how you can visualize the data in a lot of ways that gives you advanced analytics beyond just what are the current conditions that we give you in our web UI. Right. I wanted to move again. So along with weather, right, we understand the importance of traffic incidents, all of that are another unique characteristic or phenomenology that we want to capture within the technology. So we have started to use our machine learning capabilities to understand traffic. And traffic comes in many forms, congestion, flow, density. But we've now been prototyping, and we're almost ready to show some of our congestion analytics that actually over time can allow us to signal you when there is an alert or an anomalous condition. So what we've been doing for a while is looking at each camera over time, and I mean seasonally. So we have 3 to 4 years, 5 years of historical data. We can go back and look at all of this historical data, each camera, using our congestion analytic, and understand where the norms and where the norms are. Thus, we can actually start to look at when we see an anomalous congestion, we can start to alert individuals. And we're starting to do that on a per lane basis. So we see this kind of capability in lane obstruction detection, in wrong way running, in variable speed control capabilities that could be that the Department of Transportations are all sort of looking or trying to find, right? So we find a normal scene, and we establish that normal scene for the character over not only the day, but we do it day and night, but even over the seasons, we're actually doing that. And then we're able to look at that over time and tell you when there's something that's not normal, right, in that scene. We're doing that single frame detection. And as the lower left image, if you look at the lower left image, one of the things that we're trying, or not trying, but we are close to actually putting out is a per lane sort of congestion capability. So from a single frame, we're going to be able to tell you whether that particular lane is congested or not congested, which is, I think, in the marketplace, something that's significantly, it's not currently in the marketplace at this time. So we're planning on not only understanding when congestion happens on, the eastbound and the west side lane, but we're also trying to understand per lane on the westbound lane or per lane on the eastbound lane, and then alert when you get this anomalous condition. All with one single frame, no video required. Okay. So I want to talk a little bit about some of the studies that we've been doing with some of our partners and also with Florida DOT. One of the biggest and most problematic weather events is fog. Fog is inherently localized, very hard to detect, very hard to predict. And as a matter of fact, numerical forecasts have a very hard time with ground fog. They're good at looking at winds and atmospherics that are a little bit above ground fog, but they have trouble with ground fog, and they really don't do visibility very well. So we partnered with a company called Praxsoft, along with Florida Polytechnical Institute and Florida DOT, and supported a fog study grant that was part of Florida to help understand or help predict, better predict fog. Believe it or not, in Florida, fog kills and traffic accidents kills more people than hurricanes. And it's just the nature of the terrain in Florida. So this was part of a fog study that we did in Florida with Praxsoft. So what we did is Harris did the reduced visibility verification. So Helios provided the accurate validation for reduced visibility situations. That was its role, right? We proved that the image processing analytics instantly relayed present weather conditions, and they facilitate a replacement of very expensive RWIS and forward scattering visibility sensors that exist with DOT cameras. So we're really looking at, Harris has really validated the fact that, right, we can use very inexpensive cameras, right, to get the same type of capability for detection of fog, right, than that an RWIS system can do that's extremely expensive to not only buy but also maintain. Praxsoft has a unique visibility prediction weather forecast model. We teamed with them. They have a primary forecast index that combines several different aspects of weather modeling and GIS to try and predict dense fog events and heavy precipitation, which of course reduce visibility. So it puts really a primary focus on future fog and reduced visibility events, are more predictive, trying to be more predictive than the generalized information from what you get from a traditional weather system, or even looking at being reactive or past. So what we're trying to do with the Florida DOT study is to give them more real-time decision-making capability. So sort of some of our results. So the study did validate, as I said, that Harris Analytics provides a very affordable verification of reduced visibility in fog conditions, and actually meeting or exceeding the performance of existing technologies. And we saw that Praxsoft with Harris combined with some of the Praxsoft capabilities, their suite of sensors, right, that they have, their site adaptable software algorithms, meaning they have a set of algorithms that can be adapted for specific locations that may be difficult, and their weather modeling show great possibilities for predicting dense fog events and heavy precipitation. So with that mix together, we saw great results from that, right? So in their 2016-2017 fog season, they had about 81 to 91% prediction accuracies with a false positive of about 7. Harris did some visibility correlation and validation with Praxoff with their model results, and then Harris extended their nighttime our visibility analytic to nighttime to provide a two-way validation solution. And over the last, I think the 2017-2018, Praxoff has showed a great improvement in accuracy, and we believe that accuracy will continue to improve as we work in together on a sort of two-way solution for detection of fog, particularly in Florida. And we think this sort of solution is applicable as we go from Florida to other states, other DOTs. Right? And it's really about improved visibility, prediction, and it's about reducing crashes, improving traffic management, decreasing costs, all of the things that a DOT, that's what their mandate is all about. So if you want additional information on this study, we can provide that information on this study to anyone who requests a study on the fog. This is a very important study because fog is probably one of the worst things that forecasts get wrong. And it kills a lot of fatalities involved with it. So I think that's all I had. I think we can open it up, Jody, for questions.
Yeah, great. Thank you, Eric. So a couple questions have already come in. Can you explain how feedback on your product gets fed back into your machine learning?
So we have an internal mechanism within our system that monthly we do an eyes-on validation, statistical validation within our system. So as I showed you before, each observation that we make within our system comes with an accompanying image that you can use to validate the observation. Internally, we do a statistical sampling across our whole network. That gives us a good indication, and it's a random, by the way, it's a random statistical sampling. That gives us an indication of where our models are failing and where our models are doing well. And when we see that the models aren't doing quite well, that particular eyes-on manual statistical validation allows us to go back and retrain. We see retrain the model. We see this a lot when we add a lot of cameras into our network. So recently we added Germany and we added New Zealand into our network. We had to go back and do another retraining of the model because it had different types of scenes or different types of images than what we typically saw in the United States. And we continuously do that type of validation monthly to try and improve the model.
Great. So that kind of ties into this next question. How accurate are the analytics?
So we look at the analytics sort of in a direct way, right? So if you're looking at sensitivity in the model, when we see an event that occurs, and actually it's kind of related to the previous question, when we actually look at statistically manually validating our data, we look at the events. So not only do we look at non-event, right? At first we look at, right, everything. So even when there's no events happening, we're looking at false alarms, right? We do a statistical sample. We also do a sample across events. So when we see events occurring, or we see an event occurring, we sample across events. And we have the capability of doing that simply because our system has a way of, showing us or correlating when we think an event actually is happening and when it doesn't. We also correlate that with some other third-party vendors for when an event actually is happening. So when we look at precision, or when we look at sensitivity of our analytics, we look at how good our analytics are in detecting when something actually is happening. And that number is somewhere greater than about 96%, with about 2% false alarms. And the other percentages are, we have camera outages, or, the camera is pointing at, at the sky, because sometimes we have no, we don't know how the source provider is providing us the imagery. Sometimes they put up a camera and the camera moves or accidentally pointed to the sky. But the event detection or sensitivity is about 96% with 2% false alarm.
Great. Next question, how many connected vehicles do you have?
So the system, the platform is set up so they can ingest just about any type of imagery pointed at it, and that imagery gets pushed through the workflow just like any other static camera. I think we currently have all the plow fleet for the Minnesota DOT and the Iowa DOT. We have another initiative that we're working with several OEMs and several tier ones that will bring, I think the first one will come online in San Francisco, that will bring actual real-time connected car data into the network. So I would say we'll probably see some level of commercial vehicle level data into the network, probably by the early, I would say maybe early spring. I don't know how many plows there are in Iowa and Minnesota. We expect on the northern states to bring as many of those plows or fleets in as we go over the next 6 months.
Okay. Next question, do you make a distinction when the images are not of sufficient quality to identify the phenomenon?
Yes, we do. And I'll come back out a little bit if everybody can see my screen. If I zoom in, I hope everybody can see the black dots on the screen. So the black dots indicate that something's happened to the camera, or it hasn't passed the quality pre-screening, and we did not make a detection. I think if I click on that, you might be able to see that there's something not quite right. Although that image looks okay, there's something not quite right with that image, and we're not making a detection because of it. And it may be because that image is frozen, right? So I'll give you an example, right? We get these sources of imagery from all different types of places. And a lot of times, some of the source providers don't realize it, but they'll provide us the same imagery over and over and over again, meaning the feed is not being updated. We actually pre-screen for timestamp, we pre-screen for frozen frame, we pre-screen for just about every anomaly that you can think of before we actually make a detection. If it does not pass that image quality, then you'll get the black dot that you see on the screen. And that way, we look at the detection. It's better to make no detection than to make a bad detection. So we have a whole host of pre-screening algorithms, and a lot of them are actually machine learning that actually look at these images before we actually make the detection.
Great. Can your alerts be pushed to me?
Yes, they can. So we have a push capability to allow you to set up, and that can even be through a third-party alert system. So if people are familiar with Zapier or if then that, those types of third-party alert capabilities are compatible with Helios, or we can do a direct push from our API for a specific alert that you're looking for.
Great. Just a couple more questions. I know we're at the top of the hour, but what format is your data in? How do I assess it or access it?
So Helios has an API. The format is in JSON. So if I go, I'll try and give you an idea of sort of, if I can do this quickly. So Helios has a complete online developers capability. So you can get at our REST APIs simply by going to the developer online site. And these are open to anybody, by the way. You don't need a password to get these. It's just helios.earth. And we can give that information to developers.
Yeah, I'll send that in the follow-up email.
Right. We have both a JSON API that gives you just a REST that gives you back JSON data, or you can use the Python SDK.
Okay, so last question that we'll take. Are you performing automated validation of camera analytics against co-localed weather station data and providing alerts where there's a disagreement?
We haven't provided an alert to disagreement, but there are plenty of our cameras that are on our WIS stations that are around the country. Now, we haven't worked out a situation where we could alert somebody if they're different from what we see from what the RWIS, but that is something that's very, very doable, right? So we know the data. We're pulling in a lot of the discrete data from the RWIS stations like road temperature. We can pull that data about what the camera's seeing, and we could alert very easily if there's a difference in the data.
All right, great. Well, with that, we're going to wrap things up. We appreciate everyone's attention on the line, and thank you again, Eric. So we're going to have the webinar recording on our website at harrisgeospatial.com, and we'll also email all the registrants the recording, the slide decks, and other information. So thank you, everyone, and have a great rest of the day.